Great, thanks for the opportunity to present. I'm Rob Ogden, CEO and founder of Terra Autonomy. Next slide, please. I'm leading a team of experts in autonomy, computer vision, networking, and large-scale services from places like Tesla, Microsoft, and GM Research. Next slide, please. So in an ideal future, transportation would be data-driven, connected, and autonomous. If you think about a clean slate designed for a smart city, everything in that environment would be sharing data. So the vehicles, the traffic lights, pedestrians, cyclists, everything would be available in a full picture of data that would allow for a high level of automation and the optimization of safety and efficiency. Of course, in reality, things are much messier, and that's because of the legacy of the built world. Most things can't or won't share data. So things aren't networkable, don't share the same protocols, or importantly, many things simply don't want to share data. So a person may not want their cell phone tracked. Uber may not want to broadcast the location of all their fleet vehicles and the like. And this means that there's a very incomplete picture of the world in data. This leads to minimal automation, fatalities increasing, and congestion compounding. So importantly, 80% of crashes could be avoided or mitigated by V2X, which is a NHTSA estimate. So moving towards this ideal could have a huge impact on society at large. Next slide, please. So how do we progress towards this connected and autonomous world given the limitations of today? Next slide, please. Our vision is called the Geomobility Cloud. It's a high fidelity 3D geospatial mobility map, contains the location and tracking of all moving objects like cars and pedestrians, the state and status of infrastructure, like traffic lights. It's software defined and massively scalable. And importantly, it's based on permissionless data capture. So like I said, there'll always be actors in the environment that aren't willing to share data. So it's important to get a full picture in data. You need to do this permissionlessly. Next slide, please. So our system uses cameras for geospatial mapping, and the benefits of camera sensing are that they're low cost, high quality, they're easy to scale, and they're already deployed at scale. So they're already deployed in the up to millions in across different locations around the world. Next slide, please. So this is a demo of our product. It's comparing us to a Bosch product called Bosch Intiox, which is doing 2D object detection. They're using a $5,000+ camera, and we're using data captured from a GoPro. Press play on the video, please. So you can see here, sort of basic 2D object detection, lagging vehicles. It's not accurate, but it's doing some tracking, but it's limited what you can do with 2D object detection. First, what we're doing is 3D geospatial mapping. So we do 3D detections of moving objects. What that means is that we can give those objects geospatial coordinates. We can put them on the 3-dimensional globe. We can view them from any perspective, like this satellite view. And this is a side-by-side. Next slide, please. So the differentiation between us and other sensing technologies is essentially that we can do a lot more for a lot less. Our hardware is based on generic off-the-shelf cameras, so we can use cheap cameras, basically sub $500. We can do 2D and 3D detection, as I showed, which is important. Classification, multi-sensor fusion, so more sensors means better quality of data, and we're cloud native. The combination of all these things means that we're scalable in a way that other technologies simply aren't. And so, particularly the more advanced technologies are very expensive and hard to maintain. Next slide, please. So a case study of this, and to illustrate it, is deploying full coverage on the I-10. The I-10 is 2,460 miles. It's one of the deadliest highways in the United States, and deploying across that entire length would cost less than $30 million, as opposed to 2.3 miles of an Atlanta Smart Corridor project in 2017, which cost $3 million. Next slide, please. We think this is coming at a good time because the American Jobs Act has allocated $44 billion to what the DOT is calling transformational projects in infrastructure. This includes billions for research, billions for deployments, and $44 billion in total. Next slide, please. And so we think that we're absolutely a transformational technology. Not only are we able to enable huge benefits in safety, as I mentioned before, but efficiency, which ties into safety because fewer accidents means less traffic disruptions. And then all these things and making people and objects move around in the environment more efficiently has a big benefit on sustainability as well. So safety, efficiency, and sustainability, which are really the three top priorities of improving transportation for the future. Next slide, please.
30-second warning.
So our data pipeline, our business model is software as a service. We have a computer vision model that can be deployed at the edge, the control center, or in the cloud. We fuse those data outputs into a 3D map and then derive analytics and alerts to service customers in the smart cities market and the connected vehicles market. Next slide, please. Competitive advantages are numerous, but to be quick, I'll just focus first mover, we're new. Network effects, we're building a literal network. There's a lot of proprietary IP into realizing this vision. And then we're supply chain neutral, so we don't see GM using a Toyota system or Tesla using a Waymo system. So we're a new link in the supply chain. Next slide, please. We have a LOI to run a pilot in the city of Los Angeles, which is going to be 1 year, and then we're moving to commercialization in year 2. Next slide, please. And our vision is to be the nerve center of global connected autonomy, enabling various use cases across automating infrastructure and vehicles. Next slide, please. We're looking for partners in government agencies, automakers and their suppliers, as well as telecommunications companies. Next slide, please. And we're seeking $4 million in a seed round currently, and are talking to many investors. We have 500K in institutional commitments and have raised less than 100K to date. And that's the presentation. Open it up for questions. My CTO and co-founder, Philip, should be joining as well.
Henry, how about you lead with your question?
Yeah, sorry. How does using the normal cameras compare to the others like Bosch, like you had listed up there?
Favorably. So, the demo that we showed is, a GoPro, right? So it's not, optimized for this specific use. We just need basically a clean data feed that we can use to, put through the computer vision algorithm.
I didn't realize they were all that clear, but that one looked pretty clearer than I'm used to seeing. That's why. That's all. Thank you.
Hey, Rob, this is Quentin from Hypergiant. Great presentation. My question is kind of where your compute is taking place, this classification, detection, tracking, segmentation. Is that happening on the device or near the device, or is that happening kind of like at a localized hub, or are you doing all that in the cloud?
I'm gonna let Philip jump in on this one if he's available.
Hey, my name's, excuse me, I'm Philip, the CTO. So the beauty of our software is that it's basically hardware platform agnostic, so we can deploy it on the edge or in the cloud. And so it's really set up to function well with whatever types of cameras are set up infrastructure in cities.
We have Colonel Stephen has a question.
Yeah, I sent this in the text chat, but have you guys worked at all in off-road autonomy?
Sorry, could you repeat that?
Have you worked in off-road autonomy?
Not personally. I don't know, Philip, if you have that experience.
Sorry, in off-road autonomy, do you mean just
for military, military ground vehicles that would be going across off-road?
I don't have experience in that. Generally, I would say this application is focused on where there are existing cameras or cameras can be installed. So it's mostly focused on either roads or basically mappable areas.
Yep, got it. Thank you.
That could include, though, for some members of the audience, things like a military base. So, an airport could even be, the inside of a warehouse. Really, the core tech is about, detecting and tracking and mapping objects in three-dimensional space.
Go ahead, Chad.
Yeah, I got two quick ones. First is, what's your plan to gain access to these cameras? And at one point you mentioned having information about the state of the traffic signals, you know, reds and greens. How do you plan on gaining access to that? And then you had a 80% reduction in collisions. That's a pretty bold statement. I'm curious how you are going to accomplish that level of safety improvement with your offering.
Sure. It's a three-part question. So the first, try to remember sorry, could you break it down and go one by one?
Access to data, access to agency data. What's your plan there?
Yeah, so the agency is will be our customer, and whether it's on at the device level or where video signals are aggregated, like in a control center, basically we don't necessarily need access to the firmware of a given device. We just need the video output, and so as long as they want us to process the data, it should be accessible. But of course, we would like to work with hardware providers, and we're talking to companies like your own about integrations and things like that.
Yeah, and then the 80% reduction in collisions. How do you get there?
Yeah, so that's just the NHTSA estimate as to what CV to X could provide, and so really that is it's just sort of parroting that statistic. But I think the idea is there that you can basically giving a vehicle, even a not smart vehicle, or even a driver via cell phone, emergency alerts or emergency braking information or things like that. You can prevent collisions, right? And so, an example, we were at an ITS conference recently talking about Tesla that on autopilot that emergency braked, but basically there was your classic like late pileup, multi-car pileup. It didn't have enough braking distance. Its headway wasn't long enough, but if you could give the vehicle knowledge that 3 cars ahead someone's already emergency braking, you can't even see them yet, or there's debris in the road, or those kinds of things. Those are all basically creating a 3D picture of the environment gives you the ability to understand and sort of operate it more safely.
Thanks. Nice presentation.
Thank you.
Jeff, you want to wrap it up for us?
Sure. Real quick question as just a follow on to Colonel Potter. Maybe it's more of a statement, but you mentioned you're doing a proof of concept pilot. I'm working off-road, off-highway autonomy, and I'm just curious, like Colonel Potter said, I'm focused on construction sites, airports, anything that isn't on a highway. Have you looked at that as more of a more forgiving first place to try, because there's less things to go wrong, and more willingness to let you try things out?
Yeah, so we're definitely looking at, I guess, contained environments, I guess, is what I describe that as a potential, way to scale initially. But we're sort of exploring partnership discussions with different kind of parties, that some that are in that category and some that are more like DOT type partners. Yeah.
Awesome. Thank you.